Alright, welcome back. We are going to finish up this section in this video, and there are 4 examples left here, so this should be a relatively short one, I hope. Alright, so our first 2 problems that we're going to do here are very similar to the last 2 that we did in the last video. So if we want to evaluate a base to a power, like 32 to the 2/5 power, usually we want to take something that's written in this form and write it in the other form instead. So let's write this in radical form. All right, so this is going to have, just copying what's here, it's going to have a radical sign. The base, 32, is going to go in here. It's all a matter of where the 2 and the 5 goes. One of them goes here, one of them goes here. The number in the bottom of the fraction here is the root. So this is going to be a 5th root, and the 2 is the exponent here. So 32 to the 2/5 power is the same thing as the 5th root of 32 squared. And I think writing it in radical form is going to help us figure out what this is equal to, right? When it says evaluate, this is a number. We just need to figure out what number this represents. Because if we've got something in a root, then we can break this number down. Now, what I would not recommend is taking 32 squared and figuring out what number that is. That's going to be a big number, and you could do it that way, but then you've got to break that huge number down. What might be helpful instead is to just break down 32. Let's see, you could do 2 and 16. You could do 4 and 8. I think that's all you could do. I'll do 4 and 8. We break it down a little more. 4 is 2 and 2. 8, I'm actually going to split into 3 2s. It's a little bit of an advanced technique when you're breaking down numbers. 8 turns into 2 times 2 times 2. You could do 4 and 2 and then break down the 4 again, but you'll end up with 3 2s there. So if you do enough of these and you break down something that has an 8 in it, that becomes 3 2s. Okay, this is broken down as much as possible. So what this tells us is that 32 is the same thing as 2 times 2 times 2 times 2 times 2. That's 2 to the 5th power. Okay, so what this does for us, we can write 32 as 2 to the 5th power. So let's do that here. So we've got the 5th root of, instead of 32, I'm going to write it this way. And that exponent of 2 is still out here. All we did from here to here is write 32 as 2 to the 5th power. So what we can do here, if we've got a power raised to another power, we're going to multiply those together. So we're going to take 5 times 2, and that makes 10. So this is really 2 to the 10th power, and we're taking the 5th root. So this is where we can do that shortcut. We can now take this exponent and divide it by the root. That gives us 2 to the 10 over 5 power. And it may seem like we haven't really done too much to get from here to here, because we've still got a fraction in our exponent. But check it out. 10 over 5 is the same thing as 2. So this is 2 to the 2nd power, or 2 squared. That's 2 times 2. 4. 4. Okay. So, yeah, there are several steps in this problem. But if you can even start by taking this and writing it in radical form, even if you can't do anything else, that tells me you know how to take something from exponential form to radical form. That's something. Once we had this, all we did was break down this base. We've done that in the past. Nothing new here. Writing it as 2 to the 5th power. Power to a power means you multiply the exponents. And then we did our trick where we take the power divided by the root, and then we just did 2 times 2. Okay? So it might look a little intimidating when we're done. That's a lot of steps. But each individual step, hopefully something that you've seen before. The only new thing here is going from here to here. All right. Let's try out the next one here. This one should work similarly to this one. So if you're feeling confident, if you feel like you could take these steps and apply it to this problem, I encourage you to pause the video and do that. Come back when you're ready. All right, let's get started. 16 to the 3/4 power. Okay, so we want to write that in radical form again so we can make it easier to work with. This base is going to go in here. The 4 is what goes outside because it's on the bottom. The 3 is on the top. It goes in here. So we've got the 4th root of 16 to the 3rd power. All right, what did we do next here? We had this, and we said we want to break down this base. So we did this. Let's do that here. This time we're breaking down 16. You could do 2 and 8 or 4 and 4. I'll do 4 and 4. Each of those is going to turn into 2 2s. Okay. So in this problem, we had 32 was 5 2s, so it was 2 to the 5th power. This problem, 16, we broke down. It's 4 2s. 2 times 2 times 2 times 2. 16 is 2 to the 4th power. Okay. If you were to multiply this by another 2, you would get 2 to the 5th power, which is 32. So we're going to know, well, we're going to know this, of course. We're going to take what we know now and write 16 as 2 to the 4th power. So we're just going to take this, change 16 to 2 to the 4th power. So we've still got the 4th root. 16 becomes 2 to the 4th power. Now I write that in parentheses here because if I didn't write either of these things in parentheses, it might be a little confusing what's going on with the exponents. Okay, so this 3 is still out here. In math, it's usually easy to just add parentheses pretty much wherever you'd like if you want things to be separated. Okay, so we've got the 4th root of 2 to the 4th power raised to the 3rd power. We've got this exponent raised to another exponent here, just like we did here. What did we do with the 5 and 2 here? Multiply. So we'll do the same thing here. This becomes 12, right? 4 times 3. So we've got the 4th root of 2 to the 12th power. This is where we can now use our shortcut. We can do our exponent divided by the root. So this is 2 to the 12 over 4 power. How many times does 4 go into 12? 3. So this is 2 to the 3rd power. That is not 6. Please don't make this 2 times 3. That's not what this is saying. This is saying multiply 2 by itself 3 times. So this is 2 times 2 times 2. That's 4 times 2, which is 8. 8. Okay. So it turns out 16 to the 3/4 power is the same thing as 8. All right. So hopefully, now that we've gone through a couple examples, if I give you a problem like on a problem set or something that asks you to evaluate a number raised to a fractional power, you'll know at the very least what to do first. And that is write what this is in radical form, following these examples. And then from there, break down your base, write it this way as a number to a power, multiply your exponents together, do your shortcut, and then just calculate at the very end. All right. I am going a little quickly through these problems. I'd be going much slower if we were in class. So if you need it slowed down a little bit, you can actually play this at a slower speed, or you can pause or rewind whenever you need, just so you know. All right, example 5. We're changing things up a little bit. for each of these, we wanted to evaluate. We wanted to get a number as the answer. The directions have changed a little bit here. This says simplify. And we've got variables in here, letters, y to be specific. So the answer to this is not just going to be a number anymore. It's going to be an expression. It's going to be something that has y in it. So what we're doing is we're taking this and we're trying to make it something simpler that still has y in it. So let's see what we can do here. We've got y to the 1/7 power times y to the 4/7 power. Y to the 1/7 power times y to the 4/7 power. So, it's an interesting thing that happens. We're multiplying these two things together. But this is similar to saying, okay, we want to do 2 to the first power times 2 to the second power. Okay, this is a different problem. This is not example 5. But if we can understand how this works, then we can talk about how this one works. So 2 to the first times 2 to the second. Let's figure out what each of these numbers is. 2 to the first power is just 2. 2 to the second power, that's 2 times 2 is 4. 2 times 4, that's 8, right? But what is 8 in terms of 2 to some power? Like, 8 is 2 to some power. What is that exponent? Well, 8 is 2 times 2 times 2, right? That's what we determined over here. 8 is 3 2's. So this is 2 to the third power. So if we have 2 to the first times 2 to the second, how do we get 2 to the third? Just by using what we have here. What are we doing to these exponents to get 3? We're adding them together. We're adding the exponents. So this is 2 to the 1 plus 2 power, which is 2 to the third. Okay, so even though this is a multiplication sign, if we've got two things that have the same base with different exponents and we're multiplying those things, we're actually adding the exponents together. Now that we know that, we can go back to this. So, we have two expressions here, two terms, that have the same base, y. They've got two different exponents, and we're multiplying these two things together, so that means we are adding the exponents. So you gotta do 1/7 plus 4/7. Okay? So all we have to do is figure out what 1/7 plus 4/7 is. Well, this is still gonna be y. Adding fractions that have the same denominator. Some people are still, you see fractions and you're like, I don't want to. If they have the same denominator, you just add across the top. So 1 plus 4 is 5, and the denominator stays the same. 5/7. Right? If you have 1/7 of a pizza and I have 4/7 of a pizza, together we have 5/7 of a pizza. So we just keep that denominator the same, don't make that a 14. Okay. So this is all we can do here. The answer is y to the 5/7 power. Super easy, right? As long as you have two things that have the same base and you're multiplying, just add the exponents. The most common mistake I see on simplifying problems like this, people take the exponents and multiply them together. They might get like y to the 4/49 power. That's doing too much work. We add the exponents here. Okay, just add. Cool. One more problem left. Just one. Again, we want to simplify, so we're going to get something in our answer. Well, there are no variables here, so our answer will be a number of some kind, but it may not be so easy as being a whole number like one of these. might end up being a little more interesting. So we want to simplify the 6th root of 16 over the cube root of 2. And there are many different ways of approaching this problem. I'm going to show one way. There are other ways that might be easier to get through, but I think this one will make the most sense based on what we've learned here so far. So, I'm just going to start by copying down what we've got. Okay. So, it might not look like we can do much here, but we can always try breaking down a number that we have in a root. So this 16, let's break that down and see what we've got. Break down 16. Have we broken down 16 so far here? Ah, we did. Broke it down right here. 16 breaks into 4 2s, so we can write it as 2 to the 4th power. Okay, so I'm actually going to change this 16. This becomes 4 and 4, 2, 2, 2, 2. So 16 equals 2 to the 4th power. I'm just going to change the 16 in here to 2 to the 4th power. Just wrote 16 again. I should not have done that. I don't want that to be a 16. I want that to be 2 to the 4th power. Okay. So, in every problem, well, in these two problems, we started with something in exponential form, and we changed them into radical form so that we could do stuff with them. When you're dealing with multiple things in radical form, especially if you're dividing like you are here, it might actually be easier to take each of these and put them back into something like exponential form. So, this is why it's important to be able to go from one form to the other in both directions. Sometimes you want to go from this one to this one. Sometimes you want to go from this one to exponential form. So, if we want to write this in exponential form, on the top, we've got a base of 2. And this is going to be an exponent of some kind. It's going to be 4 over 6. So we've got 2 to the 4 over 6 power here. And then on the bottom, we've still got a base of 2. What exponent is here? Well, this is a 3, but what is the exponent on the 2 here? There isn't really one written here, so we assume it's a 1. So this exponent is going to be 1 over 3. So we've got 2 to the 4/6 power over 2 to the 1/3 power. Anything that you immediately want to do here? Does this exponent bother you at all? Maybe not bother. Is there something you can do with this 4 over 6? You can reduce it, right, to 2 over 3? Let's do that. So we're taking what we've got here, we're just changing 4 over 6 to 2 over 3. This is 2 to the 2/3 power over 2 to the 1/3 power. Okay. So, I want to go back to the problem we did here. If we've got two things that have the same base, different exponents, and we're multiplying them together, what did we do to the exponents? We added them. Right? So if we're multiplying two things, exponents get added. Multiplication turns into addition. Check out what we're doing this time. We're not multiplying the two things. We are dividing. We've got two things with the same base, 2 different exponents, and we're dividing them. If multiplication turns into addition with exponents, what do you think division turns into? Did you guess subtraction? If you did, that's it. So this is the same as 2 to the 2/3 power minus 1/3. Okay? So we take these exponents and subtract here. So what is 2/3 minus 1/3? Well, our base is still 2. 2/3 minus 1/3. Subtraction, just subtract across the top if your denominators are the same. So 2 minus 1 is 1 over 3. There we go. So your answer here, to simplify this, it's 2 to the 1/3 power. You could also write that in radical form if you wanted to. That would be the cube root of 2, and this exponent here would be a 1, but you don't have to write that. Okay? So, what you've learned from these examples, if you want to evaluate a number to a fractional power, a good first step, write it in radical form. Then you can break down the base and go from there. We also learned a couple rules about exponents. If you're multiplying two things that have the same base, add the exponents. Multiplication turns into addition with exponents. And division turns into subtraction of exponents. It only works if you got things with the same base, but in this class, the bases will be the same if you're asked to do something like that. Don't worry about that. Okay? So you did learn a couple new rules. You've got this a little more on lock now. So for your next e-learning day, we're done with this section. You'll have a problem set to work from. It'll be a few problems that are very similar to the ones we've gone through in these two videos. So if you've taken good notes, or you can bring these videos back up, work through those problems. See what you can do. If you've got questions, shoot me an email. Say, I'm struggling with number 1 or number 4 or whatever. And I'll get back to you with ways that you can tackle that. Trust me, it'll help if you do that. I promise. All right, so that's it for section 6. I guess we'll see you in the next video. Have a good one.